Have you ever felt that the topic of domain-driven design is too big and you struggle to understand how to start applying its concepts in your own project? Or maybe you had a hard time to combine them with other well-known practices such as unit testing and technologies such as relational databases and object relational mappers? If so, you are on the right track. In this course, I'm going to show step by step how to grow an application from the very beginning to a fully fledged solution with the DDD principles in mind. You will see the full process of building a software project using such concepts as entities, value objects, aggregates, repositories, bounded contexts, and domain events. Not only this, I will give detailed annotations along the way and explain why we make one decision over another. You will learn what DDD concepts are applicable in what particular case and why it is so. My name is Vladimir Korikov, and this is the Domain-Driven Design in Practice course, in which I'm going to show how to apply the domain-driven design principles in a real-world application, the thing I've been doing for more than 5 years now. Let's dive in. I believe the best way to learn how to apply the principles of domain-driven design in practice is to actually go through the whole process of creating an application, and this is exactly what we are going to do here. In the first module, we will talk about the core principles we will follow in this course. I will also give a quick overview of the basics of domain-driven design. You will see when the approach DDD proposes is applicable and why. I'll also introduce you the problem domain we'll be working in and show the UI of the application we'll be building throughout the course. In the next module, we will start the development with some basic functionality. You will learn the differences between entities and value objects, which of them to use in your codebase and why. I'll also show the best practices for working with both concepts. In the third module, we'll discuss persistence and how to keep the domain model isolated despite the requirements relational databases and object relational mappers impose. Next, I'll show how we can combine the existing classes in aggregates. You will see how to find proper boundaries for aggregates and what trade-offs are there when it comes to defining an aggregate in your domain model. In Module 5, we will talk about the repository pattern and how it correlates with aggregates. In the sixth module, we'll introduce the second bounded context and we'll discuss the guidelines behind the notion of bounded context itself. You will learn how bounded contexts relate to subdomains, how to find boundaries for them, and more. Next, we'll talk about domain events. We will start with implementing domain events in a classic way and we'll see what drawbacks it introduces. After that, we will come up with a better approach. In the last module, we will look at possible ways of evolving the codebase further on and discuss the several anti-patterns in the world of DDD. This course is going to be code-heavy with a strong focus on the quality of the code. We will implement the project using the C# language, so you will need at least some basic experience with it. Besides C#, I assume you are familiar with the theory behind domain-driven design and at least read the Blue Book written by Eric Evans. I also recommend you to watch the Domain-Driven Design Fundamental course by Steve Smith and Julie Lerman here on Pluralsight. Every good practice has its own limits. It's important to understand that domain-driven design is not a silver bullet. There are different kinds of projects and DDD is applicable to only a fraction of them. Let's elaborate on that. Every software project has a set of attributes, the most important of which are the amounts of data it operates, performance requirements, business logic complexity, and technical complexity. The amount of data an application works with may vary a lot in the modern days. Although the most of the software we know works with data that can fit a single database instance, it is not necessarily the case for other types of projects. There are a lot of solutions that analyze and process huge amounts of raw data, or in other words, big data. Performance requirements is another attribute that can differ for various types of projects. A simple utility, for example, often doesn't have much of them, as opposed to an online trading platform, which usually has a strict requirement to return any call with no more than tens of milliseconds time frame. Business logic complexity refers to the degree to which the problem domain a software works in is complicated. For example, a CRUD application that performs basic create, read, update, delete operations doesn't carry a lot of complexity with it. At the same time, an ERP system, which automates a big chunk of the company's activity, must model all the processes the company acts upon and thus handle a lot of complex business rules. The business logic complexity of such a system may be extremely high. The last attribute I'd like to point out is technical complexity. You can think of it as of complexity of the algorithms you need to implement to make the software work. A good example here is low-level programming for embedded systems, where you need to deal with many of the hardware systems manually. Alright, so where do the domain design practices fit in this picture? The techniques DDD proposes are useful if and only if the project you are working on has a lot of complex business rules. DDD won't help you if you work with big data, need to achieve outstanding performance, or program against hardware systems. The only purpose DDD concepts serve is to tackle business logic complexity. So if you need to create a Twitter-like application, domain-driven design won't help you much with that, because the challenge in this type of software comes out not from its business rules. The business logic itself is pretty simple in Twitter. What makes it hard to implement is the great performance and scalability requirements. A typical example of software with complicated business logic is enterprise-level applications. It is true that most of enterprise projects don't have outstanding performance requirements. They operate moderate amounts of data, and developers working on them usually don't have to deal with technical complexity by their own, because there are plenty of tools that abstract out this kind of complexity for them. The biggest challenge in such projects is to handle business logic complexity in such a way that it would be possible to extend and maintain the solution in the long run. That is exactly the task that domain-driven design practices are aimed to solve. They help us create code which not only fully covers the problem, but also does it in the simplest and thus the most maintainable way possible. Let's set some groundwork and talk about the basic principles we'll follow in this course. In my opinion, there are two core principles in software development to which every programmer should adhere in most cases. They are YAGNI and KISS. YAGNI stands for "you are not gonna need it" and basically means you should implement only the functionality you need in this particular moment. You shouldn't try to anticipate the future needs, because most of the functionality you develop just in case turns out to be unused and thus just a waste of time. KISS stands for "keep it short and simple." This principle is about making the implementation of the remaining functionality as simple as possible. The point here is that the simpler your code is, the more readable and thus more maintainable it becomes. These principles are important because they help solve two major problems we face when building software projects: shortening the time needed for development and keeping the codebase maintainable in the long run. The beauty of domain-driven design is that its practices complement these two software development principles. It allows us to extract the essential part of the problem domain and simplify it, removing most of the unnecessary complexity. The ability to express business logic in the clearest way possible is a single trait that makes domain-driven design so appealing in enterprise-level applications. It is hard to overestimate how important that is. The most difficult task in the modern business line software is to keep their complexity under control. There is only this much of complexity we can deal with at a time. If the code exceeds it, it becomes really hard and at some point even impossible to change anything in the software without introducing some unexpected side effects. Extending such a project becomes a pain and usually results in a lot of bugs. This, in turn, slows the development down and may eventually lead to failure of the project. Uncontrollable growth of complexity is one of the biggest reasons why software projects fail. Domain-driven design helps prevent it. You will see that in this course we make a continuous effort to keep our codebase as simple and as expressive as possible. Let's highlight the main concepts of domain-driven design. In this course, I assume you already know the theory behind DDD, so I'll keep the description short. The first one is the notion of ubiquitous language, that is, the language structured around the domain model and used by all team members to refer to the elements of that domain. You might have noticed that in many projects, domain experts and developers use different sets of terms when they talk about the domain. This difference leads to misunderstandings and slows the overall development process down. The notion of ubiquitous language helps eliminate the barrier. Domain-driven design suggests us to explicitly point those differences out and adjust the terminology to comply with a single ubiquitous language. Let's say, for example, that you have developed a sales system. In this system, you have a class called product, which is an atomic sale unit. Let's also say you notice that the domain experts refer to this element as both product and package. In this case, you should call attention to this disparity and suggest to use a single term to avoid confusion. The concept of ubiquitous language also means you should keep your codebase in sync with this single terminology and name all your classes and tables in the database after the terms in the ubiquitous language. All this helps bridge the gap and set the groundwork for efficient communication. Another important part of domain-driven design is the concept of bounded contexts. Often, an application grows so much that it becomes hard to maintain its codebase as a whole. Code elements that make sense in one part of the system may seem completely irrelevant in another. In this case, the best solution would be to separate these parts from each other explicitly. That is where this concept helps us. It allows us to clearly define the boundaries of these parts, hence the name bounded context. If your system consists of two parts, one of which is sales and the other is support, it would be a good decision to introduce a separate bounded context for each of them and explicitly state the relation between them. We will see how we can define bounded contexts in our codebase in the future modules. The third concept is the notion of core domain. Domain-driven design states that the main part of any system is its business logic. Not all, but the most intrinsic piece of it. That is, the problem the software is meant to solve, its core domain. In the sales application example, there might be lots of business logic, but not all of it is essential. For instance, you might have a bookkeeping functionality that can be easily delegated to an external software. It is easier to do that because it is not the core problem your application is built for, and it's cheaper to just buy an existing solution rather than trying to implement it from scratch. Domain-driven design proposes that we always focus the most of our efforts on the core domain. These concepts, ubiquitous language, bounded context, and core domain, are the most important parts of domain-driven design. You can think of them as of the strategic elements of DDD. The other notions, such as entities, value objects, and repositories, comprise the tactics of how you should build your software project.